Okay guys, so we are finishing 13.4 today. We're still talking about side angle side congruence. But now we're going to be proving triangles are congruent using our congruent statements, but we're not going to be doing any measuring of any kind. So no distance formula, no protractors. This is just going to be off of triangles with either given measurements or no measurements. So how do we determine what sides and angles are congruent? Congruent line segments and congruent angles are often denoted using special markers rather than giving measurements. So I will sometimes give you triangles with absolutely no measurements at all, but I'll have special markers that tell you what sides are congruent or not. Slash marks can be used to indicate congruent line segments. When multiple line segments contain a single slash marker, this implies that all of those line segments are congruent. Double and triple slash markers can also be used to denote other line segment congruence. So take a look at the notebook page right underneath. So we have segment AB, and do you guys see how there's a single slash through it? What segment is congruent to AB? DF, because it also has a single slash. Now, even though I didn't give you any measurements, those slash marks mean that those two sides are congruent, okay? What about BC? Is BC congruent to AB? Why? Because it has two slashes. What segment is congruent to BC? ED. Does that make sense? So sometimes there's not going to be any measurements given to you at all, okay? What about angles? So let's return back to the paragraph. Arc markers can be used to indicate congruent angles. When multiple angles contain a single arc marker, this implies that those angles are congruent. So it's the same idea except with arcs to denote congruent angles. Double and triple arc markers can also be used to denote other angle congruencies. So it's not in the notebook page at all, but if you guys look at problem number 1, notice how I give you arc markers instead. What angle is congruent to angle X? Angle T, because it has one single marker. What angle is congruent to angle W? R, because they have double arcs. Does that make sense? So now we're going to be determining if triangles are congruent using side, 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 or side, angle, side, based only on information that the problem gives us, okay? So what we're going to do for this first part is we are just going to write what is called congruent statements, represented by the markers in each diagram. So congruent statements mean that what are the different statements that show congruency. Now, when we start looking at angles like this, sometimes it can be confusing as to which angle we mean. So, for example, if you guys notice angle right here where the T is, there's also another angle that's made by BTR. Do you guys see that? So BTR, there's this big angle right here. So sometimes we want you to write your angles with all of the endpoints and the actual angles in the middle. So let's practice with that. So STR, that is this angle right here. Yes? STR. So let's do angle STR. And we need to determine which angle is congruent to that. Since we're going in the order STR, so the flat side to the middle to the top, we need to write the congruent angle in the same order. So that would be BXW. Oops, sorry, angle BXW. So angle STR, going this way, STR, is congruent to angle BXW. Does that make sense? So you have to list the endpoints in the same order that we're going. So will you guys do the exact same thing for the other angle? So let's call it SRT. So angle SRT. That's the one with the double arc marker. SRT. So will you guys write what angle is congruent to that one in your notes? Okay, guys, so if we went SRT, what angle then would be congruent to SRT? BWX. Easy? Not too bad? So what I want you guys to do with your groups, I want you to do the exact same thing except for part B. Now this time there's two angles that you need to write congruent, and there are two line segments you need to write congruent. Make sure you write them in the correct order, but work with your groups here. Okay guys, let's check it. So I'm going to do the segments first. So in my notes, I'm going to write it as segment TD. So if I'm going TD, what segment is congruent to segment TD? DZ. So segment DZ is congruent to segment TD. Okay. Let's do the angles now. So I'm going to do angle TDM. What angle is congruent to TDM? DZC. Yes, angle DZC. Okay, easy? So we can use writing congruency statements and these arcs and slash marks to determine if diagrams or if triangles are congruent using side angle side or side side side, depending on what information is given to us. So let's look at this example down here. We want to determine if triangle ABC is congruent to triangle DCB. So we're going to actually draw some things on this triangle. So we first have side AB, and it's 10 centimeters. Is there a congruent side to side AB? Yeah, what side? Side CD. So I'm going to draw a single slash through each of those. Okay. So down here where it says, on number 2 where it says write the congruency statement, let's write that statement now. So that is side, or segment AB, congruent. Is it, does it go in the order CD or does it go in the order DC? If we did AB, CD. So let's do segment CD. Okay, so segment AB is congruent to segment DC or CD. Okay. Is there anything else that you guys see that is congruent? CB. What would CB be congruent to? Let's look at angles. Do you guys see any angles that are congruent? Angle ABC and angle what? DCB, right? What is the measure of both of those angles? 90. So those two angles are congruent. So let's write that. So angle ABC is congruent to angle DCB. So we have to go in the right order. Okay, so we just said that this angle is congruent to this angle. So what congruence theorem do you think we're going to end up using here? Side, 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 or side, angle, side? Side, angle, side. So we have this side, and we have this angle. So the other side that we need is BC, and actually B was on kind of right on track here. What do you guys notice about segment BC? Eric, what do you notice? It's connected to both triangles, right? It's connected to triangle ABC here, but it's also connected to triangle DCB here. So can we say that they have a congruent side? Yeah, they share the side. So is it the same length? Yeah, so put a double slash mark through that to indicate that it's a shared congruent side. So how would we write that? Segment BC is congruent to segment CB. If you gave me segment BC is congruent to segment BC, I'd probably still take it. So, did we prove that triangle ABC is congruent to triangle DCB? Yeah, so I want you to write that at the very end as your conclusion. So triangle ABC is congruent to triangle DCB by which theorem? Side, 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 or side, angle, side? Side, angle, side theorem. So after you're done writing your congruent statements, tell me what your conclusion is so that the two triangles are congruent, and tell me which theorem you used. So we used side, angle, side. Was there enough information given in this triangle to prove that they're congruent using side, side, side? Was there any way we could have proved AC is congruent to BC or BD? But we don't have any angle measurements. We don't know what this side measurement is. So then we couldn't use side, side, side. So depending on the information that they give you, we'll have to determine which theorem we want to use. So that's what we're going to do on the other side. So look at number 3. There's 2 problems here. I'm going to start part A with you, but then I'm going to have you guys try it on your own with your groups, okay? So what we're going to be doing for number 3, parts A and B, I give you 2 triangles. I need you to determine what theorem you're going to use to prove that they are congruent, and if they are congruent. So you're going to need to write the congruent statement. So let's take a look at part A, and I'll help you set it up, and then you guys are going to finish that one, okay? So part A, we want to know if triangle ABC, so ABC going this way, is congruent to triangle ADC. So we have some measurements that are given to us. What things do you guys see that are congruent? BC and CD. So put a single slash through those. What about anything else? BA and AD. So put a double slash through those. Do the measurements actually really matter? No, they're just given to us to show that they are congruent. Do you guys see anything else that could be considered congruent? A, C, and CA, so put a triple slash through that. So what theorem do you think you're going to use to prove congruence here? We have 3 sides, so side, 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 right? So what I want you guys to do right now is write the congruency statement. Okay, so for part B, we're going to be able to use side, side, side because BC, this guy right here, is congruent to DC. AB, so this segment here, is congruent to AD. And then CA is congruent to CA. If you put CA as congruent to AC, that works as well, okay? But because we have 3 congruent sides, we can say that the triangle ABC is congruent to triangle ADC using side, side, side. So let's look at part B. I want to know, is triangle ABC, so this triangle right here, congruent to triangle DEF? So let's take a look at what we know. Do you guys see any congruent sides? BA is congruent to ED. Okay, so we should put single slashes through there. Anything else that you see as congruent? Hold on. EF is equal to BC. Can you prove that? But no measurements are given, so we can't assume. Is there a measurement given for anything else? Okay, so we notice, first of all, do you guys notice that the 2 angles are congruent? So I would put an arc through there. And then they give us something very, very interesting. They give us the length of AF and the length of CD. What do you notice about those lengths? They're congruent, right? This length is congruent to this length. Now, do these little pieces make up the entire leg of the triangle? No. So we also have to be able to make a conclusion about this part right here. What do you guys notice about the squiggly part? FC is equal to what? AF. Does it tell us that this one is 6? So you can't assume that it's 6.
So FC is equal to CF.
FC is equal to CF because it's shared, right? So if this piece is shared, because look, we are looking at this triangle right here, right? So this leg, AC, has EC and AC and AF in it. So if we know that this part is shared and these two parts are the same, what can we conclude? They are congruent. So our statements would be segment AB, let's start with that one, is congruent to what segment? BE. We also know that angle BAC, because we're looking at triangle ABC, so the triangle goes all the way to here, is congruent to what angle? EDF. So we have side angle, and then we have another side that is congruent. What are the two sides that are congruent? AF is not a side of the triangle. AF is a piece of one of the sides of the triangle. You have to use the entire side of the triangle. So what's the entire side? AC. Okay, segment AC is congruent to segment DF. Do you guys see that and why that works? Because FC is shared by both of the legs of the triangle, but we also know that the piece that is missing are equal, so we can conclude that the entire legs are equal to each other. So are the two triangles congruent? Yes. Using which theorem? Side angle side.
But what about the little side segments that are in there too? Like, what about AD and DA?
AD is equal to DA. That is true, but the triangle is not triangle. The triangle doesn't go all the way from AB to D. The triangle goes from AB to C.
So all you're trying to find out is one triangle?
Correct. So she said, we know that AD and DA are shared, but because AD is not part of any one of the triangles, because our triangle goes from AB to C and from DE to F. So we can only use the sides of the actual triangle. Okay. This stuff is pretty, sometimes can get pretty tricky, and you need to make sure that you are giving congruent statements that are true and that you can prove. So, for example, there was no way for us to prove that EF is congruent to BC because no measurements are given. So you can't use that. You cannot assume anything. You have to only use what is given to you. Okay? So that is congruence statement.